Hey folks, welcome to lesson 3.2b, standard lesson, very similar to last night. You're going to have a review, you got your video work with your pause problems that you could show, 4 guided problems, we got 4 challenge problems. You'll be doing some work on 3.2b, and you are going to be also, if you're interested to get done early, you want to push yourself a little bit, I'll have a challenge there that you can do, it won't be required. Alright, let's go ahead and take a look at our review problems for the day. I'll move myself up so you can take a look at these. Spend no more than 5 minutes working on these. Let's see how you did. Okay, and you had an addition equation. Did you isolate it? Did you line up the equal signs? Did you subtract 14 from both sides, or did you just subtract 14 from this side? I know it's tempting, but it's about the process. Alright, m equals 10. Good. Oh, these should cross off. Make sure you show that as well. Alright, next one, write equations for these phrases or expressions. Twice the number decreased by 10, that's 2n minus 10 is equals 6. 2 times the sum of a number, j and 10, so 2 times j plus 10. The quotient of a number and 3, so that's division, n divided by 3, is 15 equals 15. 7 times the difference between a number and 4. You were right there. Alright, my friends, it is time for your video. I will catch you on the rebound. See ya. Hey Valley Metal, welcome back to another math lesson. Today we're going to be solving subtraction equations. Before we do that, let's go ahead and start with our trivia question. Denominations of U.S. currency are currently in circulation today. We'll be back with that after our instructions tonight. Well, officially tonight, our target is I can solve subtraction equations using the inverse operation. Dive right into a problem here. Brinley had a bunch of old hockey sticks in her garage. She sold 7 at the family garage sale. Now she has 3 left. Write and solve a 1-variable equation. Isolate the variable using the inverse operations. This is just like the process that we went through last night. But last night we had addition equations. Now we have subtraction equations. A subtraction equation, of course, has subtraction in the middle. So in the first couple of lessons of this chapter, we learned how to write these equations. And so now we can safely say that here are the hockey sticks she had. She got rid of 7 of them. She has 3 left. How do we isolate the h? How do we get it by itself by using the inverse operation? Well, the opposite of subtraction is addition. So we add 7 to both sides. Those 7s will cross off. We end up with 3 plus 7 is being equal to h, or h is equal to 10. We've balanced both sides. We've lined up the equal signs, and we put a line underneath the addition to show that now we're rewriting this equation here in a more simplified form. Throw it in, check it. 10 minus 7 is 3, and we are off to the races. Let's take a look at our must-know words tonight. Not much new. We got subtraction equation. That's just an equation where subtraction is the operation, like x minus 2 equals 8, or x minus 3 equals 6. We solve them by isolating the variable and using the inverse operation. So we have subtraction, so we solve with addition. We add 3 to both sides. These guys cross off, we end up with x is equal to 9. So by using the inverse operation, we can isolate the variable. So last night we did addition. They were written with addition. We solved with subtraction. Tonight, they're written with subtraction. We're going to solve with addition. And you can probably guess what the next lessons are going to be. Okay, let's take a look at a couple of problems, and I'll have you try a couple of pause problems. All right, here we have a minus 15 equals 2. Well, subtraction equation, how do we isolate the variable? That's our goal. How do we get rid of minus 15? Well, we're going to add 15 to both sides. When we do that, these 15s will cross off. You have a minus 15 and a plus 15. That leaves nothing but an a. 2 plus 15 is 17. Let's just check our answer. 17 minus 15 equals 2. Let's check our form. Equal signs are lined up. Good. I did the same thing on both sides, not just on one side. Good. And I drew a line underneath to show the separation between the steps of the problem. Thumbs up, duds. All right, let's try one more. Here we go. 78 equals b minus 42. Now I flipped it around a little bit, but we can do this. We still have we have to get rid of this minus 42 to have b by itself. So we add 42 to both sides. The 42s are going to cross off, hopefully. I think I'm going to have to do these by hand. 42s will cross off by themselves. And we're left over here with 78 plus 42, or 120 equals b. Pop it in, see if it works. 78 equals 120 minus 42 every day and all day long in California. All right, 2 pause problems. Let's have you take a look at these. Go ahead and pause the video and isolate the variable, line up the equal signs, draw the line, do everything you're supposed to do. Simple problem. Follow the process. That's right. I don't care about the answer. I just care about the process. Yeah, if I cared about the answer, I'd give you harder numbers. All right? We isolate it by adding 6 to both sides. You end up with, cross those out, make sure you show the cross off. You end up with n equals 30. Check it. 30 minus 6 equals 24. Boom. Done. One more. And we're on to the ticket to the show. All right, let's see how you did. Got to get j by itself, so we're going to have to add 16 to both sides. 40 equals j. See if I forgot to put it on there to cross those guys off, or else I just can't find them very well. There we go. My 16's crossed off, and 40 equals j. Double check it. 24 equals 40 minus 16. All day long. All right, here are your 2 ticket to the show problems. And let's take a look at the trivia question. What denominations of U.S. currency are in circulation today? Well, we've got the 1, 2, 5, 10, 20, 50, and 100. Some interesting things about it. I kind of get into this geeky stuff here. Let's just make this just a touch bigger. Which one of them do not feature a president? Well, he was a statesman, and Benjamin Franklin was, so he wasn't a president. And this is Hamilton. He was I think it was under Lincoln that he was the Secretary of Treasury. He wasn't the president. The rest of them are all presidents. Are there any discontinued currencies? Yes, there are. We used to have a $500 bill with McKinley on it. That baby was history, not in circulation anymore. We also had the $1,000 bill that had Cleveland on it. That one's not in circulation anymore. We even had a $10,000 bill with Chase on it. He was also he was the Secretary of Treasury. Something's fishy about that guy, though. I'm not exactly sure what, but think about it. You'll get it someday. All right. So some of these larger bills, the Federal Reserve started taking them out of circulation, destroying them in 1969. So as of January 14th of this year, there was only 336 $10,000 bills known to exist, along with 342 $5,000 bills, 165,000 roughly 165,000 $1,000 bills. There was also a $100,000 bill, but it was really a gold certificate and never circulated. It was from 1934 to 35. That had Wilson on it. All right. Thanks for listening. Hope you learned something about subtraction equations and also about U.S. currency. See ya. Okay, you're back. A little more 3.2b action here to work through independently. Remember subtraction equations? They just have a subtraction sign in the middle, so it's x minus 2. X plus 2 would be an addition equation. We're using those inverse operations, like we have subtraction here, subtraction equations, so we're going to add to isolate this variable, to get it all by itself. And again, those railroad tracks are optional. Some of you like doing them, and that is just awesome. Make sure you put that line under. Make sure you line up your equal signs. All of those things. That's why we're using the simple numbers. It's all about the process, not the answer. Very good. Here are 4 guided problems we'll do together. Go ahead and jot those 4 down real quickly. Leave yourself a little space to work, and then we'll run through them. All right. Well, how are you going to get d by itself? Add 11 to both sides. The 11's crossed off. D equals 50. Try this guy. Well, got to get rid of the minus 29, so we're going to add 29. Plus 29, minus 29, they cross off. You got m equals 86. Try this guy. Yeah, I reversed it a little bit. Still got to get rid of the minus 20. So we add 20 to both sides. We isolate it down. We got 50 equals k. Try that next one. Got to get rid of the 19, right? No. Got to get rid of the 10. You're always getting rid of what's with the variable. So you got a minus 10 there. We got to get rid of that by adding 10. We've isolated the t because those guys cross off. We end up with 29 equals t. All right. We talked about these last night too. Some of these ones that are going to involve some negative numbers. So just remember that m minus a negative 1, well, that's the same as m plus 1, because remember, you can double shot that. Minus a negative is the same as adding. A negative 1 plus a negative 2 is negative 1 plus a negative 1 is a negative 2. You just add the negatives together. And then these ones here, you got 1 plus a negative 3. Well, you're at 1 and you're going to add a negative 3. These are different signs. You have a positive and negative. So you find the difference here. And the difference between 3 and 1 is 2. And it's a negative 2 because if you think about it in a number line, if you're over here at 1 and you're going backwards because you're adding a negative 3, you're going to get to 0 and you're going to get to negative 1 and then you're going to end up at negative 2 when you take those 3 little jumps. All right, so try this one here. We have n plus a negative 36 equals 8. It's still a subtraction equation because n plus a negative 6 is just the same as n minus 36. They're the exact same thing. When you add a negative, it's the same thing as subtracting. So these are the exact same. Yeah, so you just add 36 to both sides, and you end up with n equals 44. Try this one on your own here then. Same thing. Yep. This is still a negative 12. You're going to add 12 to get rid of it. You end up with 19 is equal to y. Try the last two. Okay, let's see. Well, minus 5. So these cross off, but now you just got this weird situation where you have minus 13 plus 5. Well, these are different signs. So the difference between these two is 8. And it's a negative 8 because this is more negative and this is positive. If not, just think about that on a number line. You're at negative 13, you're going to move, because you're adding, you're going to move 5 to the right and you'd end up at negative 8. And let me just move myself up so you can see this one here. This guy here, we got to get rid of that 6. So we subtract it. Yeah, I wrote an addition equation. Yeah, just challenging you. Negative 8, because here you have a negative 2 and a negative 6. So negative 8 plus 6 would be a negative 2. All right. Lovely. Here's what you're going to do. Independently, 12 problems. You got these and these guys down here. Let me make them big, so if you don't want to, I've attached this to the assignment, so if you want to, you can put it in notability, or you can just write them down. I did the first one. It's got to look like this, folks, or don't even bother doing it. Use the process. Okay. Here's 6 more. Yes, you may use a calculator. Yes, the negative numbers are optional. You don't have to do them, but what the heck, give it a try. You got a calculator. It says right there, challenge problems. May have some negative numbers in it. All right, here are the answers to those. Again, these are just the answers. I just want to make sure the real work is just make sure that you followed my model where you subtracted or you added on both sides. You line up your equal signs. You put a line underneath, but some of the bottom ones, you might just want to double check and make sure your work looks good. All right, that looks great. The quiz, those of you who get done with the quiz a little bit early or working at home and just want to a little challenge yourself on something a little harder, take a look at these questions right here. There's a little chart up here that will be used for some of the questions, and see if you can figure out the answers. There's 2 more. Here are the answers to those problems. All right, thanks for listening. You've been a lovely audience. Have a good day.